says triangle DEF is isosceles. So what kind of triangle am I going to draw? Isosceles.
Two equal sides.
Please make sure you draw isosceles. You know it's got two equal sides. When you're drawing this, when they don't give you something, you need to draw it. If you draw a triangle that looks like this, and then you look back at it 2 minutes from now and you say, oh, it's equilateral, they didn't tell you that, right? So you got to make sure you're only using what they tell you. They tell you it's isosceles, and D is the vertex angle. So where am I going to put D at on my triangle? It's got to be the one in between the two legs. That has to be your vertex angle. Then does it matter where the other letters go?
No.
No. What do we know about angle E and angle F?
They're the same.
They're the same. Good. All right? You got to make sure you know those parts of an isosceles triangle. They tell us segment DE, that's this segment over here on the side, is x plus 7. You can't do these unless you draw a picture for them. DF is 3x minus 1. I shouldn't say that. You can do them. Ignore that. That's a 1. You can do them, but good chance that you're going to mess it up. And then EF is 2x plus 5. We want to find the length of all three sides. What equation can I set up from all that information that they gave us? X plus 7 equals 3x minus 1. How come not x plus 7 equals 2x plus 5? We don't know that they're equal, right? They could be, because it could be equilateral also, but right now all we know is that these two are equal. Did it matter where we put that D at in relationship to those two sides? Yeah, it made a big difference. So we solve this. End up with 7 equals, what's 3x minus x?
2x
Two.
minus 1.
5 by 2. What's x equal?
4 equal x.
All right, x equals 4, 4 equals x. Did they ask us to find x?
Find S and a measure.
So they wanted us to find x, so that's one of our answers, 4. Then we want to measure each of the three sides. How am I going to find those?
X plus.
Plug them in, right? So just wherever you see x, put a 4. Wherever you see x, put a 4. 4 plus 7 is what?
11, so you know that.
So one of our sides is 11, and Harry's right, this side over here better also be what? 11. Does that mean this one down here has to be 11?
No,
No.
13.
It's 13. Those are our 4 answers. X was 4, one side was 11, the other side 11, last side was 13. Next question, yes, Ethan.
Can you do 28?
28. So everybody got that before I erase it? Triangle ABC is equilateral, so this time, when I draw this triangle, what do I know about it?
They're all three congruent.
So where do I have to put A at?
It don't matter.
Doesn't make any difference. A, B, C. Ginger changes hers up and she's got A up here, B over here, and C over here. Makes no difference. It's going to come out the same because all three sides are the same. They tell us the measure of angle A. Oh, before I do that, even before I read any of this, what do we know about angle A?
60 degrees.
60 degrees, good. What do we know about angle B?
60.
60. What do we know about angle C?
60.
That's all stuff that we know, not even looking at what they told us yet. They told us angle A right here, this angle, is 6x plus 18. Before I go any farther, can I set up an equation to find x?
Yep.
What do we know about 6x plus 18? It should equal 60, so we can just set up that equation. Some of you get confused because sometimes we want to say this angle plus this angle plus this angle equals 180 and set up an equation from that. This time it's easier, just set up this has to equal 60 because we know that angle is 60 degrees. Have your calculators out, help me here in a second. 6x equals, what's that?
Two.
42? Everybody agree with Dawson on that one? Now what? What's that give us?
7.
Is that our answer?
No, we gotta put that.
What'd they ask us to find? Oh, so that's part of our answer, right? Let's go back and let's read some more. Angle B, that's this angle right here, is 3x plus 2y. Well, it's a good thing we didn't start with that one because it's got two variables in it. But what do we now know about x?
Equal to 7.
So where I see that, I can plug in 7 right there. What's 3 times 7?
21.
So it's 21 plus 2y. Now what equation can we set up? That 21 plus 2y should equal how much?
60.
Should equal that 60. So we set that up. 21 plus 2y equals 60. What's that give us?
39.
Everybody agree with that? Divide by 2.
19.5.
Y equals 19.5. Is it all right for y to be 19.5? It can be a decimal. Did they ask us find anything else other than x and y? Is that it? That's all they ask us find? So those are our 2 answers. Are there other ways we could have solved this? Yeah. All right. Things that we could have done. And you probably don't want to do it this way because we'd have to deal with systems of equations. If we know that all 3 of these angles are 60, and this one's 6x plus 18, what's this one have to be? These 2 angles are the same, and one of them 6x plus 18, what's this one?
6x.
So we could do 6x plus 18 there. All right? And what we could do is we could say the 3 angles of a triangle. You might want to plug your ears right now if I'm confusing you. The 3 angles of a triangle should add up to be how much? 180. So 3x plus 2y plus 6x plus 18 plus 6x plus 18 should equal 180. Collect like terms, we got what?
15x.
15x. 2y.
36.
That's 36. Let's go ahead and do this. What's if we're going to move the 36 to the other side? So what's 180 minus 36? 144. Now that's a fine equation, but what's wrong with it?
You got 2 variables.
It's got 2 variables. If we have 2 variables, we need 2 equations. So we could go back and say, okay, if we need 2 equations, we know that that right there equals 60. So 3x plus 2y equals 60.
Times that by negative 1.
Now we could, what Harry's saying from algebra, he remembers from algebra last year, you get either the x's or the y's to be opposites of each other. He's saying multiply this one by -1. He might have meant the top one, I don't know. So we got negative 3x minus 2y equals a negative 60. Get rid of this equation now. We add them straight down. We get 12x. The y's cancel out. That's the equal sign there. What's 144 minus 60? 84. Divide by 12. Somebody help me out and divide by 12. 84 divided by 12. I can't write anymore. What is it? 7?
Yeah.
So x equals 7. Is that what we got doing it the other way? All right, so could we have done it this way? Do you really want to do it the longer way? If you can find the shorter way to do it, then do it the shorter way. All right, but using systems of equations, once we found x, what could we do with it? Plug it back into one of these. I'd probably plug it in right here. And then just solve for y. I'll do one more question if it's quick. All right, Izzy. Sorry, Jacob, she had her hand up before I seen you. 39. Make sure your names are on these. Please make sure your names are on them. 39, again, they tell us it's an equilateral triangle. If it's equilateral, what do we know about all the sides? They're all equal. So So does it really matter where I put the letters?
No.
No, so I'm just gonna go ahead and write in these numbers. 3x minus 2 is one of the sides. One side's 2x plus 4. And another side is x plus 10. What can we do with all that? Most common mistake that most of you are going to make on a problem like this, watch closely so you don't make this mistake, and make sure you're watching now, because I don't want Ginger coming to me later and saying, well, you did that one problem on the board like that. Yeah, when I was trying to show you what not to do. All right, so make sure you don't do this. 3x minus 2 plus 2x plus 4 plus x plus 10 equals 180. Why won't that equation work?
Because that's not that easy.
You're not dealing with angles. It's a very common mistake that I see a lot where they give you three expressions like this, and you say, oh, it's a triangle, so it's got to add up to 180. The angles have to add up to 180, not the sides. So don't do that. Now, what equation could we set up?
2x plus 4 equals x plus
2x plus 4 equals x plus 10. Now, Jacob didn't even use that. Does that matter? No, you're just trying to find x. So you could have set this equal to that one. You could have set this one equal to that one. Could have set these two equal. Any of those equations would have been fine. How do I solve this?
Minus x and minus 4. X equals 6.
Is that what they asked us to find?
Yes, and they ask us to find a measure of the side.
Oh, they want the sides also? So what do we do with that 6? Plug it in. So I'm going to plug it in right here because that's the easiest spot. What's 6 plus 10?
16.
Let's measure this side then.
16.
Measure the other side.
16.
Now a lot of you think, well, why would you write that down? Because when I write this down, that tells me, or whoever's grading this, that you know what? All three sides are equal to each other in an equilateral triangle. So it's important to have all four answers. You could have, and on the EOC test, they might accept it doing it like this. You know, you put x equals 6, and then put all three sides are 16. Maybe write it out that way. All right, make sure your names are on those. You're going to pass them up. You're going to pass them forward. Miss Carol, since you got nobody pass it forward to, you pass it over, right? Pass it forward. Once they all get up here, pass them to your left so that Ethan gets them. Pass them to your left so Ethan gets them all. As I'm walking by him, I'm collecting. Go ahead and start copying this down. Second set of notes. Another thing, maybe you might want to get notes off somebody from last time. Thanks, sir. If for some reason I still have your binder laying over here, no, days and nights. Also, I have one paper that I forgot to pass around last time. Will make me do extra work today, so I can make sure the grades are in there right. Doesn't have a name on it. Pass it around. If it's yours, put your name on it, then lay it back up here on my chair. If it's not yours, just pass it on to the next person.
It's a female because
So
it's
yours, just put your name on it, lay it on my chair. All right, bisectors. Anybody have any idea what this says?
Use perpendicular bisectors.
Perpendicular bisectors. Perpendicular bisectors, big part of what we're going to do this whole chapter. You've got to understand perpendicular bisectors. Perpendicular bisectors, it's just telling you two things. All right, again, math people very, very lazy. If they can tell you more information in fewer words, that's what they're going to do. So perpendicular bisector. If I have a segment and I tell you something is the perpendicular bisector of that segment, what do you think it does to that segment? It bisects it, so it splits it into two equal parts, two congruent parts. What else do you think it does to it? Makes right angles. All these are right angles. That's all a perpendicular bisector is. So as soon as you hear something's a perpendicular bisector, you know you got two congruent segments. You know you got four congruent angles, four right angles. An angle bisector, what's an angle bisector again? We talked about them earlier this year.
Splits an angle into two.
Splits an angle into two congruent angles, good. Be able to write equations for perpendicular bisectors. This is probably the hardest thing that we're going to do today. And again, it's not really hard because we've already written equations for lines and you did it last year. It's just it's got a process and you got to go through that process and it takes a few steps. All right, first, just a couple of terms here. Equidistance and perpendicular bisector. We just talked about perpendicular bisector. What do you think equidistance means?
The equal distance.
Same distance, equidistance. So if it says equidistance, just because it's a big fancy word, don't let it confuse you. Just means that it's the same distance from whatever it is that you're dealing with. Same distance from two different things. Dawson, I'll tell you what I'll do for you and what you can do for me. Today during intervention,
Finish that picture?
finish that.
That's what I was gonna do.
Now listen to me. I'll give you full credit if you finish it, and not only do you finish it, but Caleb, I think Jeremiah's absent. Who else is in here? Get with a couple of those other people and help them finish it also. All right? Can you handle that? I don't have gas in there. Huh?
Gas.
What?
Look there right now.
Yeah, you might be right. Maybe their New Year's resolution was to turn into a different person. And they are actually doing it.
They've let him down too many times to get.
Trust the process.
Gotta show me, I can't. Did you guys have a game
So all of a
today?
sudden, like, yeah, just kind of like a straight line with a straight line, do it that way.
It's just, you want me to just turn it so it's like this? Do it on your paper that way. I don't care. Confuses you? Just draw it on your paper that way. So equidistance, same distance from two figures or 2 points or whatever it is. Perpendicular bisector. This is going equidistance is going to be important here in a minute because we're going to cover a couple of theorems, and those theorems seem hard for students to understand most of the time. Perpendicular bisector is a line that bisects and is perpendicular to a segment. Remember, it's got to be a segment that's being perpendicularly bisected. That's probably not the correct grammatical way to say that, but it has to be a segment. You cannot have a perpendicular bisector of a line or an angle or anything else. It's got to be a segment. When we read this, and you'll probably never see me write it out this way again, this says line DE is the perpendicular bisector of segment AB. So what two segments in that picture do we know have to be congruent? Segment AC and segment CB. And name me an angle that we know has to be a right angle. DCA, ACD, give me another one. DCB, so on, so on, so on. There's four of them, right? We know that all four of these have to be right angles. So you know all that information. Before we do this, before we write down these two, this information here, I'm going to do this. I need somebody to come up and draw me a segment with two endpoints. Draw me a segment with just two endpoints. Nothing hard about it. I'm not trying to trick you. So I'm not trying to make you look stupid or anything right at the moment.
Not yet.
Yeah, not yet. Draw me a segment. Try to make it. Use the actual pen. Harry needs to try to make it so it's an actual segment. We want it to be sort of straight, not just like the normal segments that we normally draw, where I don't care what it looks like. I just say, hey, this is a segment. We want it to be sort of. Everybody. So that's his segment. Now what I'm going to do with that segment, I'm going to measure it. I'm going to start at 10 because my ruler is not very good. It looks like it goes out to about 62. So 62 minus 10 is 52. Somebody help me out with your calculator. What's half of 52? 26. So I need to be out 26, or it needs to be 26 over. Let me reline my thing here. So that'd be right about there. Does that look like about the midpoint?
Yeah.
And I'm going to call it point M. Then I'm going to take my protractor here, and I'm going to do this. I'm going to go down here to 90, put a little mark. My pen's a little off. I'm going to draw this through there. Who I missed? So that's my line. What do I know about this angle right here? 90. This would make Jaden a little happier because Harry drew it straight across and mine went straight up down, right? So we know that that angle is 90. So this line is the perpendicular bisector of that segment. Now what I'm going to do is I'm going to pick a point at random, just some point that falls on that line, since I already sort of have a point right there. That's my point, so we're going to call it point E for Eversole. What do you think is true about point E? Anybody come up with something that they think might be true about point E? Other than it's a point and it's round and it's whatever. If I look at this distance right here, if me and Jacob are both standing on point E, and I tell Jacob to walk to point J, and I walk to point C, guess what's true about those two distances? They're the same every single time. I could measure it and try to show you. This one goes from about 10. My drawing might not be too good, but it goes from about 10 to 46. This one over here goes from about 10 to 46. No matter where I pick that point on that line that's the perpendicular bisector, guess what's true about the distance from here and distance to there? It's the same, no matter what. If I pick some point up here, same distance from here as it is from there. From here to there, same distance. Every single time. Now, if I could erase some of that, which I can't, when we had the first one right here, we had two triangles. Guess what's true about those two triangles? They're right triangles, that's true. They're congruent to each other. Right? We know that these two distances are the same. We know this distance same as that distance because it was the midpoint. What do you know about this middle side? Same as itself.
It's a bisector.
So what could we use to prove these two triangles congruent?
Side, side, side.
Side, side, side. No matter which two triangles we drew there, if we draw another segment, and we know that that's the perpendicular bisector, and we draw some triangle here, some triangle there, know that that's the same as that, that's a right angle. These two triangles every single time are going to be what to each other? Congruent. This big triangle is going to be what kind of triangle every time? Isosceles. So what do we know about these two angles? They're congruent, so on and so on. There's all kinds of stuff that we know. All right? Back to these. When you write this down, if I was writing it down, just write down, you don't, again, I don't care about theorem 6.1, perpendicular bisector theorem, and put some form of this sentence right here. Same thing down here, converse of it, put some form of that sentence. You don't have to draw all the pictures and all that. Just write it down so that you can understand it. Abby understands it best by writing it all down, then write it all down. Molly only needs a little bit of it, write down what she needs. Kiara, did that seem too hard to understand? Think you can handle it? So I was probably just making a big deal out of it. You guys are tons smarter than all the students I had in the past, so that when I try to use inductive reasoning and say, oh, students have trouble with this all the time, and I've seen the pattern over the last 20-some years. It was dumb of me to use inductive reasoning this time, right? Because you guys understand it completely. Huh? Speak for yourself. All right, so the perpendicular bisector theorem says any point that falls on the perpendicular bisector is equidistant from the endpoints of the segment that's being perpendicularly bisected. All right? So any point that would fall on this line right here, some point right there is going to be the same distance from A as it is from B. Some point right there is going to be the same distance from A as it is to B. Every single time. The converse of that, what's converse do again? Switches the hypothesis and the conclusion. So the converse says, if I was to draw something like this, tell you that these two lengths are the same. There's some line going down through here, if I could hit my point there. And I tell you that these two lengths are the same. Guess what's true about these four angles right here?
They're all the same.
They're all the same, and they're what kind of angles?
Right angles.
They're right angles. So it says sort of the reverse. If you know those lengths, and those lengths are the same, then that line's got to be the perpendicular bisector. All right, so it just says the converse, the reverse of it. And there's two different ways you could use it. You could use it, say, okay, I know that these two segments are the same, those two segments are the same, so I know all these have to be right angles. Or you could know that these two links, I'll be out of the way in 1 second, these two links are the same, that's a right angle. Well, then that tells you that P has to be the midpoint and those two segments have to be the same. Lots of different ways you could manipulate that around. Pretty important theorems because they can be used a lot. I'm not much of an artist, but a lot of things in art, I always go back to surveying because that's something I actually know something about. A lot of things in surveying use these two rules. They say, okay, we set this up and I bisect this distance from here to here. I make sure I'm right in the middle and I make a right angle with it. Then any point that falls on that line is the same distance from this end as it is from this end. We happen to be building some kind of square for some reason. We want to make sure it's square.
Can't you just put right angles to indicate that it's square?
If you're drawing it. But if you're actually building something and you want it to be right angles, I don't even want to go there because it's going to be too confusing. But if you want it to be right angles, and you hope that, Dawson, when you get old enough and you have somebody build you a house, you hope that they don't just say, yeah, it's a right angle. By the time they get done, that first angle wasn't a right angle, it was off a little bit, and then they start adding more and more stuff to your house, what happens?
It's gonna lean your house.
It gets more and more and farther off. Had a group, I just built a barn a few months ago, and I was standing there watching the guys put up the sheet metal on the roof, and they got down to the last piece of sheet metal, and they measured. And one guy was up at the top of the roof, and the other guy was down at the bottom edge of the roof, and they measured, and the one guy goes, yeah, it's 3 feet 5 3/4 inches. Then the other guy came down here, yeah, it's 3 feet 7.5 inches. So they were like 2 inches off. So that last piece of metal, you can't tell it, but that last piece of metal that they put on the roof it's 2 inches smaller at the top than it is at the bottom, because they were out of square that much over the whole thing. Now at the beginning, when they put up that first stud, those first studs, were they off by 2.5 inches? Was this leaning 2.5 inches this way? No, they would have noticed that. But it was off a little bit, and then that made the next thing off a little bit, off a little more, off a little more, and by the time they got up there to put the metal on the roof, they were off 2.5 inches over, I think the roof's about 16 foot from peak to the bottom. And that's quite a bit to be off for 16 foot. If line GB is a perpendicular bisector of segment OT, tell me what you know. Give me something here that you can tell me has to be true.
Angle GNO is right angle.
GNO is a right angle, so I'm going to mark that a right angle. Segment ON is what? Congruent to NT, so those two have to be the same.
G to O and G to T is the same distance.
So from here to there is the same distance as from here to there. So we know that. Give me something else.
O to B, B to T.
Sorry, I missed B.
B really is.
Those two have to be the same.
G and B.
Now, are these going to be parallel to each other? I think that's what Harry was saying, right?
Wait.
I said G and B.
G and they're not parallel.
And maybe parallel
They're not.
if the 2 points are the same distance from.
They might be parallel, but we haven't got there yet, and we will get there. They are going to be. All right, and we'll prove that. What else?
Would point G and point B be the same distance from
So point G and point B, same distance from where?
Yeah.
Yep. So this distance from here to there, well, no, not necessarily. I'm sorry. Could be, but not necessarily. I shouldn't have said that. What do we know about the rest of these angles? They're all 90 degrees, all right angles. A lot of information that you know. Next one. Is line GB the perpendicular bisector of OT? So from the information, this is part of what your homework's going to have on it. From the information that we have there, we're trying to decide, is this the perpendicular bisector of this segment?
Yes.
What has to be true for it to be the perpendicular bisector? Splits into two congruous segments, which it does, and it forms a right angle right there. So is it? Yes. Any point on what? The perpendicular bisector. So any point on line GB is what from O to T? Equidistance. Equidistance. So what that means, if I pick some point right there, we call it point E. What do we know about that distance and that distance? It's got to be the same. It's got to be the same. Find segment SR. So we're going to find segment SR. Where is segment SR?
Top.
The top one? What is it? 6.8. Everybody agree with that? This is the what for segment RP? The perpendicular bisector. See, it's perpendicular to it and it bisects it. That means any point that falls on that line, like S does, has to be the same distance from P as it is from R. So if this is 6.8, that has to be 6.8. Find segment EG. Be careful.
The top.
19.
19. How'd Harry get 19? All right.
19.
First thing, is this the perpendicular bisector? It's perpendicular to it. It doesn't look like it bisects it, but if these two are the same, then what do we know about these two? They got to be the same. So it is the perpendicular bisector. If that's 9.5, that's 9.5. They didn't ask us to find that, though. They asked us to find this whole thing. So how would we do that? Add them together and you get 19. So make sure you're careful what they're asking you for. Find segment CD. How can we manage to do that? What do we know about line BD? It's perpendicular bisector. So what has to be true about these two? They got to be equal. They got to be the same. So what equation can I set up?
3x plus 14 equals 5x.
Very good.
Minus 3x.
Subtract 3x. 14 equals 2x. What's x equal?
7.
Now, is that what they ask us to find?
No.
What they ask us to find?
This is ugly.
CD, this side, right? So we're going to plug, well, we could have put it in down there.
35.
3 times 7 is 21 plus 14, 35. So the answer there would be 35. Is ZX a perpendicular bisector? Yes?
We don't know. What was the,
Do we have enough information? We don't have enough information. Just because it's perpendicular to it, do we know for sure that it bisects it? Do we know that Z is the same distance from those two? So we need some more information. So we'd have to write not sure. Not enough information. Angle bisector. Go ahead and write this down. was upset because we already went over angle bisector a bunch. What is an angle bisector? What's an angle into
Two congruent.
two congruent angles? Right, hey. What is you on your multiplication facts? It's 0 times 9.
0.
That's a hard one.
That would have been so cool if I got it all.
So if ray TH bisects angle NTH, bisecting it tells us these two angles have to be congruent. So if this angle's 52 degrees, what's this angle? 52 degrees. Neither one of those are anywhere close to 52 degrees, but
Does that mean that TN and TS are the same distance as well?
nope, not necessarily. But it is going to mean something that we're going to talk about here in a minute. We're going to skip that again for a second. I'm going to do this. I'm going to draw an angle and I'm going to try to draw it. I'm going to try to draw one that's fairly close, being straight and everything. Somebody give me a cute angle, something nice.
32.
32, I heard. 32 is going to be somewhere about right in there. Give me some letters.
ABC.
So we got angle ABC here. We know it's 32 degrees because we made it that, right? So I want to bisect it. If I bisect a 32 degree angle, what am I going to be at? 16. That's somewhere about in there. I was doing good till that one. So now I have that. If I pick some point on this angle bisector, this is what Dawson was trying to say. If I pick some point on this angle bisector, does it have to be the same distance from A as it is from C? No. But there is something that has to be true if it doesn't have to be the same distance from those points that we already have, but it has to be the same distance from that side as it is to that side. But when we find distances, what has to be true about these angles right here? They have to be perpendicular. They have to be right angles. Right? So this distance and that distance always has to be the same. But you can't just draw it to two random points and say, is it the same? Because it's not going to be. Maybe I pick some point way back here. Is that going to be the same distance from E as it is from C? It ain't nowhere close. All right? But what is true, any point you pick on that angle bisector is the same distance from this side of the angle as it is from that side of the angle. And that's what these two theorems say that we passed up here. Same idea here. Angle bisector theorem, write down as much of that as you need to write down. I would probably just write down that sentence right there. If it helps you a little bit, you might draw the picture on this. What the angle bisector theorem says, if this angle is being bisected and we pick some point out here, point D, we draw a segment back to here that forms the right angle, segment back to here that forms the right angle. Guess what has to be true about those two blue segments?
Equal.
They got to be equal. They got to be congruent to each other. Then the converse says just the opposite. If you know these two distances are the same, guess what's happening to the angle? It's being what? Bisected. So it's sort of the same thing as the perpendicular bisector theorem, but it's a little different. So make sure you don't get those two theorems confused or mixed up. Started to ask you, Elijah, don't you guys have a game day?
Yeah. But Kobe took.
Any good?
Yeah, they're like football schools, so they're pretty strong. Last year they were pretty good
Are
too.
they good in basketball this year?
Last year they were. Well, I assume because we did this year. You want us to write theorem 6?
I don't want you to write that, but you need the converse there. Unless you can just remember it. That's up to you. So it'll be good. I just need to come in and have on the board quiz.
What is theorem?
Theorem 6.5.
What is theorem 2.46?
Write it down there.
We should have the theorem listed there.
No, that wouldn't help.
Is it not
We
in
don't,
the theorem?
yes. Why would that? We don't even need a quiz.
Is there like an equation to find out how many like different theorems there are?
That's what Kate
Those are not definition, like life's worth of study. I hope
Just murder
you're like so offended. I'm like, I actually am though. Like, I'm just trying to help all of you guys. Like another theorem that says there are so many theorems. Too many.
So again, this first theorem, if you know it's an angle bisector, any point that's on it is equidistant from the sides of the angle. If you have a point that's equidistant from the sides of an angle, then it has to lie on the angle bisector. That's the second theorem. If you wanted to start writing
We use the same photo.
your name on it, I collected it. If you want to start writing, I'll put this back up during the intervention for you, or you can just. Thank you very much. I don't even have to finish my statement.
No.
Harry, did you do anything over your 4-day weekend?
I decided it best to sell my Camaro, trying to find me another car. Found a car. I just gotta sell my car first.
What year Camaro you got?
I have a 98. Over Christmas break, I found the first gen Camaro for sale. And I could afford it. My dad took a look at it and showed my grandpa and said, kind of experts. This is back when they were, back when my dad was riding.
Like, put your words on
Back when my dad was my age, they used to work with cars like that all the time. I found the first, second ship for sale, it was 79, they had a tree accident in it, and it was one of those flood vehicles. And someone put on a cheap coat of paint, made it look real nice. My grandpa went to it, and I let her I don't want that car at all. I'm wanting one so bad. I can't find it for a good price. I mean, it had almost no rust on it, except for the seat. They had that thing propped up.
All right. Any point on ray AD is equidistant from sides sides of angle BAC. So again, to be able to say a distance, these gotta have right angles here. So if I was just to draw something like this, do we know for sure that those are the same length? They gotta be right angles where they come together to meet the sides. But on this one, since they both have right angles there, we know that those two have to be congruent every single time. Look at this. How can we find segment PS?
5x equals 5, 6x minus 5.
It's an angle bisector because these two angles are congruent. So what has to be true about these two segments? They got to be congruent. So 5x has to equal 6x minus 5. Subtract 6x on both sides.
Negative 1x comes up x.
Gives us negative 1x equals negative 5. A lot of people make a mistake right here when they do this because they move everything to one side and then don't know what to do next. When you get something like this, what do you have to do to figure out what x is? Change the sign, so what's x equal? 5. Now they wanted to know how long PS is. What are we going to do?
It is 25.
Plug it in, so it is
25.
25. Don't make these harder than they are. Next one. Find the measure of angle GFH. GFH, that's this angle right here. That's the whole thing there. We look right here, what's true about these two distances? They're congruent. If those two distances are the same, so J is the same distance from that side of the angle as it is from that side of the angle, guess what's happening to the angle? It's being bisected, right? So if that's 42, what's this angle?
13.
Now they wanted the whole angle, so what do we got to do?
84.
Add them together, so the answer there would be 84 degrees. Next one's number 1.
5.
X is 5, everybody agree with that?
Yeah.
Perpendicular bisector, so these two distances have to be the same, so that's 5. Number 2,
4.
is that a perpendicular bisector?
Yep.
So what has to be true about those two? Got to be congruent, and somebody's already figured out what's x equal? 8.
That one's 2.
Angle bisector here, so what has to be true about these two segments?
Here it says 2.
X equals 2. Some of these you can solve in your head, right? This one. Angle bisector, so what has to be true?
That's it.
Those two angles have to be congruent. These two sides are congruent.
X equals 1.
2x plus 9 divided by 3 minus
X equals what?
1.
I am.
Did you get confused? You want me to do it? I will. So we look at this. We look at this right here. Is it bisecting that angle?
Yep.
Yeah. So what's true about? Those are the sides, right? What's true about the distance from here to there and the distance from here to there?
Same.
They got to be the same if they're both right angles there. So 2x plus 9 should equal 3 minus 4x.
Minus 4x equals 6x. Minus 9x equals negative.
So you got 6x plus 9 equals 3. Minus 9. What do you get? So 6x equals negative 6. So we were a little off. What's that give us? X equals negative 1, right? Is it all right for x to be a negative 1?
Yep. It could be anything.
Yeah. All right, now the hard stuff. Give you a minute to write this down. Ethan says nothing's ever hard to him. Might want to write this down. Writing equations of perpendicular bisectors. Now, the first thing I say up there is graph the original one. You really don't have to graph the original one, or the original points, the original segment, but it might be helpful so you can see it. So if you needed graph paper, you could grab graph paper up here. And then you just gotta do these 4 steps. 5 steps. Can't count. I know, but I didn't see 6 down there at the bottom. So I thought, okay, 5 and 1, subtract 4, or subtract 1, it's 4. First thing you're going to do, you're going to find the midpoint of the original segment. Then you're going to find the slope of the original segment. 2 formulas that we talked about last class. Then you need to remember if 2 lines are perpendicular, or 2 segments are perpendicular, what do you know about their slopes?
Opposite.
They're opposite reciprocals of each other. So we're going to use that. Then so we find the slope of the perpendicular bisector. It's got to be the opposite reciprocal. Then we use that and the midpoint, the coordinates of the midpoint, to figure out what B is for the perpendicular bisector. Then we write the equation in y equals mx plus b form. And we'll do an example. It might be a good thing to have this example. Might be a good thing to have an example in your notes there. Jen is not at all, this is just so simple. She's not at all confused by it. She probably doesn't want to write down any example.
She's just a know-it-all.
What did you have here for this week?
Worked in my barn most of the time trying to get stuff squared around. Still trying to get stuff moved in.
Trying to get in there.
Sort of.
We need one.
It's called. I don't have it insulated completely yet.
My dad has a barn over at our house. He has a heater, but even with the heater on, it's almost like cold work.
That's what mine is right now. I bought a thermometer to stick in there, and all weekend it ran about. Thermometer staying between 20 and 30 degrees. It never, even with my heater on.
Our walls aren't insulated. And
We only have 3 walls and 2 back doors. I got one of my walls is insulated. I've gotten that far, but the other 3 aren't.
What are you putting in your barn?
Insulation.
I have a
What are you using the barn for?
To keep things in.
batting cage in there. And
He's
I
got a
have
casino in there, dude. He's got like
right
30
now.
slot machines. He's got the big car.
He's got the pool table.
all that stuff's in my basement. Which I can have a second. I do have 1 slot machine. I have 2 others that I haven't picked up yet, and a pool table, 2 pinball machines, foosball table, an air hockey table. Sounds like field.
We should have a field trip to your barn.
That's in my basement.
Well, we should make more.
My grandpa moved over
Maybe
to a
you
new
have
house.
to
We're working on it right now. The garage is technically, technically it's a barn, but it's not big enough to be called a barn. We have this little backhoe. We can barely fit the backhoe in, and it's got the big excavator arm on the back of it, and then it like sticks out and only takes out the barn if we try to hold it. We had like that much of the entire. It's hilarious.
Listen, to finish answering your question, other than the batting cage, I have a tractor in there right now. Have my Rhino in there right now. I have a 19. Yeah, not that kind of Rhino. I should have known that. I have a 1964 GTO in there right now.
Well, now you're just trying to brag.
Have a. What else is in there?
There's laws for that.
Yeah, bring it to work day.
Most of it's not mine. Most of it's stuff that we're trying to sell. All right, so if I do this, you might want to write this down, write an equation for this. We got about 10 minutes. I'm going to graph this. Again, if you want to graph it, that's sort of up to you. I might suggest it just to make it easy, but this is going to show you how to write this equation. Back up here, let's go. So I'm going to graph mine, write down at least this part, and then we're going to actually work it out over here in a second. Negative 2, 3, so negative 2, 3. That's that point right there. My pen's a little off, so I'm not hitting the point exactly. That's point P. 4, 1. 1, 2, 3, 4, 1. That's right there. That's Q. We're trying to find the perpendicular bisector of that segment. We're actually trying to write the equation of the line that's the perpendicular bisector of that segment. So I did number 1, I graphed it. What number 2 say to do? Find the midpoint. So I'm going to take these points and I'm going to find the midpoint. Remember, to find the midpoint, you add the x's, divide by 2, add the y's, divide by 2. What's negative 2 plus 4?
2.
2 divided by 2?
1.
So that's one of our answers. What's 3 plus 1?
4.
4 divided by 2?
2.
That's the midpoint. That's the midpoint of this segment. If we went to 1, 2, we should be right on the midpoint. Notice my segment's probably off because it's supposed to be right there. But that should be the midpoint. What did the third step say to do?
Find slope of slope.
Find the slope. Now we could find the slope by using the slope formula. We could find the slope by doing rise and run. So it might be easier if you graph it to do it to just do rise and run. Here, how much do I go down? 2. So that's a negative 2 on top. Then we count over. Count for me as I go. So over 6, what's that reduced to? Negative 1/3. So we got the slope, we got the midpoint. What did the 4th step say to do?
Slope of perpendicular bisector.
So now we want not this slope, but we want the slope of the line that's perpendicular to it. What do we know about the slope of the line that's perpendicular to it? Opposite reciprocal. So what's the opposite reciprocal of negative 1/3? Just be a positive 3, right? 3 over 1 or just 3. So that's the slope that we want. That's the slope of our new line. What's the 5th step say to do? So we're going to use those two. Y equals mx plus b. Ain't none of this really all that difficult. It's just a lot of steps. You're going to plug in here. You're going to plug in there. You're going to plug in there. That's going to leave us with just b, and we're going to solve for b. What do we put in place of y? The y coordinate, which is 2, equals, what do we put in place of n? 3. What do we put in place of x? The 1 from the midpoint up there. What do we put in place of b? B, right? Then we just do a little math. What's 3 times 1?
3.
3 plus b equals 2. How do we solve for b?
-1.
Minus 3, so b equals -1. What's the 6th step say to do?
Use y equals mx plus b plug in.
So we're going to use that y equals mx plus b again. This time, instead of plugging into all 3 of these spots, we're going to plug in here, and we're going to plug in there. What's the slope? What slope did we find? 3. What y-intercept did we find? -1. That's our equation. So it just takes, you just got to do those steps. Now, it took me like 5 minutes to do that. Should it really take you that long?
No.
I did a couple of them before you guys got in here. And knowing how to do it, just going through the steps real quick, each one took me about 1.5 minutes, 2 minutes maybe. So you find the midpoint, find the slope of the original lines, both of them, find the slope of the new line, use that midpoint and that slope of that new line to find b. Then once you know b and you know the slope, use those two together to write the equation. That's your assignment, page 306. Somebody want to read that out loud to me?
3 through 20,
Keep going.
25, 29, 30, 34, 39,
Slow down. 34.
39 through 44.
Again, next time when we come in here, it'll be your job. I walk around, I check Ethan's paper, then Ethan's going to come up here. He did it, puts a check in his box. All right? If you don't remember your numbers, I'll tell you your numbers again. But hopefully after a couple of times, you'll be able to remember your number, right?
That's the only reason I got it. I don't know, man. Jason, they do not know the way.